This set of activities is about relationships among several different ways of thinking about distances and centrality. Before beginning, you'll examine 2 activities that even first-grade children can work on successfully. For these first-grade problems, just as in the case of problems for you, impressive solutions aren't likely to occur unless the problems are stated in such a way that it is possible for problem solvers to assess for themselves which of several trial solutions is best or most sensible. For young children, familiar stories are often even better than real-life situations to encourage them to use their heads, instead of simply relying on some adult to tell them whether their work fits the adult's conception of correctness. In fact, this whole course is about learning to judge for yourself whether statistical procedures are sensible, rather than being simply politically correct, according to some presumed authority. The first problem is about the train. The task for the first graders is to figure out a configuration of train tracks that doesn't have any dead ends, and that uses up as many pieces of track as possible. If you compare this task to the toy train problem that you did in class today, notice that one thing that made your task difficult was that train tracks couldn't turn sharp corners. Your task would have been much easier if you were making paths for walkers or people riding bicycles, which can turn sharp turns. For example, imagine that the mountains that you were given were real life-sized mountains, and that your task was to find a path that never exceeded a 10% grade, and that would work for bicycles. You could have made paths that involved switchbacks. Switchbacks are paths that go back and forth up mountains, as shown here. The second example problem is about Beauregard the frog who lives in Sugar Swamp, where the lily pads look something like this, and where the frogs only take proper hops. Proper hops are jumps that only go one lily pad at a time in a horizontal or a vertical direction. So, the task for first-grade children was to find a new home lily pad for Beauregard so that the sum of the distances would be as small as possible to the lily pads where each of his 3 best friends live. First graders can solve this problem by counting the total lengths of 3 paths like the ones shown here. And, first graders' best solutions sometimes notice patterns, like the one shown here, that shows the total distance at each point. Your first homework task for today is to do a more difficult version of the Beauregard problem. In your case, Fathom will randomly locate 12 points on a grid that goes from 0 to 100 in both the horizontal and vertical directions. Then, your task will be to move 2 sliders to find a home for Beauregard that minimizes the sum of the distances to all 12 of his friends. Then, ask Fathom to randomize the data several times so that you can find a rule that will automatically give the location of where Beauregard should locate his home. Now, you might be wondering, why would anybody care about such a strange notion of distance, which is measured only using horizontal and vertical lines? You'll begin to get hints about some answers to this question in the 5 short homework tasks that follow this problem. All of these problems use Fathom or Sketchpad software. The first task again looks quickly at distances using only horizontal and vertical paths. The second task investigates relationships between straight-line distances, which are shown in green, and vertical and horizontal distances which are shown using red dotted lines. As you move the point P, notice that the locations that minimize these 2 sums are the same. The third task investigates relationships between straight-line distances and squares based on these distances. This time, notice that, as you move the point P, the locations that minimize these 2 sums are not the same. The fourth task shows how the famous theorem of Pythagoras is related to these various notions of distance, and how they are related to sums of vectors. The theorem of Pythagoras says that the sum of the lengths of the 2 sides of a triangle is equal to the square of the hypotenuse. Finally, The fifth task investigates relationships among all of the preceding kinds of distances. This time, notice that, as you move the point P, the locations that minimize the top two sums are the same. And, the locations that minimize the bottom two sums are the same. But the locations are not the same for the top two and the bottom two sums. So, in this example, the centers that are found using straight line distances are not the same as the centers that are found using squares of distances. We'll need to look for such differences as we proceed through this course, and we'll need to pick the measures that make the most sense in different situations.